Snehal ma'am?
I could not hear you.
Ma'am, I was asking where the correct participants were have already joined the earlier session also. So I mean, I just want to know from where we can start. If there are any new participants, we'll try to introduce and then go into the complexities.
Yeah, we have few new participants.
Okay. So what I'll do is
Last time, Trinath sir only Snehal madam and Gavinde sir was there. Otherwise, all are new.
okay. So what I'll do is I'll do a
Yeah.
quick run through of the introduction PPT. I will not spend much time on that. And I'll list some of the key features of NEPLAN software by demonstrating the software. And then based on the questions which you have, we'll try to further dwell into it. Is my screen share? Okay, present now. No, that's the entire screen, right? Yeah. Now, where does it show that it is? Okay. Please let me know if you're able to view the screen.
Yes.
I think this is not needed. Yeah. So first of all, very good evening to everyone, and thanks for this re-session on the NEPLAN software introduction. So NEPLAN is a software which is used to allow the European Union and across the Asian countries for modeling and analysis of power systems in specific. So to set the expectations right, this is a software in which you can perform the tasks of the which can be handled in a transmission system or a generation system or an industrial system or a distribution system for doing the power system analysis from the steady state point of view and transient stability point of view. And this software to an extent can handle the switching EMTP simulations, that means cable switchings and all, very not to the detailed level of PSCAD, but to an extent it can be performed. But mainly the application is for doing the analysis of the power system from the steady state point of view and transient stability point of view. And it is also used to analyze the major problems that are faced within the power system networks, like reactive power compensation, for example. How much reactive power compensation should you be providing? It can be used to do voltage stability analysis, in which you can analyze transmission systems and distribution systems to identify the weakest points in the network. The regular load flow and short circuit capabilities are anyway there, which we'll look into. And then perform from industrial point of view for harmonic analysis or power quality analysis, we would call, and reliability analysis. So these are the areas of application in which this main software is used for. So it is a very it has a very long history. It is being developed from almost 1983, and and it is a ABB co-developed software, and we have been using this for all our studies from long. So here is a quick glance of the modules that are present. This covers the software. Main advantage of NEPLAN is that it is not limited to a particular area, because if I look at various other softwares which are present, for example, if I take PSSC, it is mostly suited for transmission system analysis. I take ETAP, it's mostly suited for petrochemical complexes and their modeling. It is more developed from that point of view. And if I look at dig silent, it is used for representation of the distribution systems and industrial systems with a heavy coding interfaces. Means it requires more in-depth understanding of each of the module. And in case you want to model even some small protection relay, there's a lot of modeling involved. It is not straightforward in modules like dig silent. Whereas NEPLAN combines the power of all these softwares. Of course, there is another SIMDIST. So SIMDIST, you can call it's more or less a analogous twin of NEPLAN, But then SanDist is mainly useful for the distribution systems and everything, and NEPLAN has integrated that capability as well now. We can integrate the GIS related data, geographical information system related data, to get on with the distribution system modeling and all. So all of these features of the software, taking the best of them and making it suitable for all the areas like transmission, distribution, and generation, also, and industrial systems. So everything can be taken up in NEPLAN, and these are the main modules that which support it. For universities, both for the undergraduate students and the postgraduate level, the software has a flexibility because it provides all the standard modules like load flow and contingency analysis, harmonic analysis, short circuit, motor starting, etc. But the main power lies in this NEPLAN programming library, which is a programmable programming language. You also find something similar in Digsilent, which is called Digsilent programming language. So you can program the and automate the kind of cases that can be simulated within NEPLAN. And also NEPLAN provides an interface to MATLAB. The dynamic models which you create in MATLAB using Simulink and other things can be interfaced with NEPLAN, and you can create dynamic model. You can experiment with the new dynamic models that are created. The only value what it adds is when you are designing some other controller or something, okay, for a research topic, or maybe you're designing something, a new algorithm for MPPT or something, then what NEPLAN provides advantage to you is you can use your MATLAB model and try to interface with the actual power system network without the additional task of creating all your dynamic simulations and everything. That code you don't have to write it in MATLAB. So you can directly model the network in NEPLAN and then use a Simulink model. I'll show you some of the examples. So use a Simulink model, MATLAB Simulink model, and interface it with the modeled network in NEPLAN, so that all the task of modeling all this power system, okay, that dynamic equations related to the power system components, that you can avoid. So you no longer are limited by limiting your scope of research up to an SMIB system or a small system due to coding limitations. So this expands really the possibility of simulating a lot of things. And there are interfaces with GIS and SCADA as explained. Of course, in university license, this is very limited, and that package details we'll look into later. So, and then these are the base modules, and then there are some distribution system related modules like optimal capacitor placements, phase swapping, which are very, very important these days, and the distribution systems are looking into this kind of modeling where they can optimally designate the phases of the customers, or where to put the capacitors on the distribution feeders. So these kind of modules are there, and mainly for transmission, and which are required are the distance protection modules, voltage and small signal stability, and contingency. Mainly contingencies are included in the package. And then there are some industrial models, mainly the arc flash calculation, which is the important package these days. And nowadays, most of the industries they have to go for this arc flash calculation because it has been made a mandate from the safety point of view, and all insurance companies they demand this particular thing to be done. It can be a multi-million company, or it is a small company. They have to comply the arc flash calculation levels, and there are many consulting assignments in the market for this, and that's where majority of the universities are working on this particular thing to assist and provide services while educating the students. So I will skip on this part. This is pretty much standard. So we have the software features we'll directly look into. I'll only tell the crux of this. It works on Windows 10 now, so that's not an issue. And you need at least around 800 MB of space to install this. So those are the main things. And for a server license, you can connect the hard lock within a LAN, or in case you want to shift to cloud, there's a cloud-based license as well. And it supports various languages, but of course for us, main thing is English. So it all does that. And in addition to this thing, one more advantage is it not only covers electric, it also has packages for water, gas, and heating. So a single NEPLAN package, if you can, if you are going for it, so later on it can be expanded into other modules as well. So without a newer license, you can expand it to various departments, and the same license can be used across. So heating networks you can use, and water networks also can be analyzed. So I'll show that when I open the software. I think these are all screenshots. We'll see it in the direct demo. Okay, so that's a brief intro. Now directly coming to the software before I go into it. So this is how the desktop version of NEPLAN looks like. As I was telling, this has water, gas, and heating modules as well. So, and some built-in examples also built in. The biggest advantage for this software is that you don't have to start from a highly technical documentation. All the modules have been built up, and there are a number of examples that are built in, and the corresponding documentation is also coming as part of the installable file. So for example, if I load flow, if I have to do something, I can just open an example and see what is there and click on the info. It will take you to the corresponding example and the documentation. So the complete documentation along with the example description, everything is given so that it is it can be learned by anyone who dedicates some time for self-learning. So in short, you don't need an instructor as well for this software. And the interface is quite straightforward. There are no databases, nothing. It is a simple file-based system. For example, it is as good as I'm saving it. If I'm doing it, it is just like a file with an extension NEPPRJ, NEPLAN project. So it is as good as you are using any Office package, MS Office package. You can make a save as, or you can just simply save it as a separate file at any location you want. And next, when you want to open the things again, you just open that file. It's just like opening a Word document or a Excel sheet which you have. You don't have to load up databases, maintain passwords for the database. All these things are not there. So that itself avoids the total complexity of maintaining the files. You don't have to load a particular library, or you don't have to work on a specific server or something like that. And also another advantage is you have libraries also in that way. Library is not a database here. Libraries can also be opened with an extension file of neplib. This is also a file-based thing, which is unlike, again, you don't have to go store it in a database and load the entire thing again. You can save simply the, actually you're not on VPN, right? You have any library? I'm sorry, just excuse me for a second. I'll be keeping on mute briefly. Oh, then great. Library files. So NEPLAN provides a library interface with a file-based system. Now, how do we go on to desktop here? Okay, yeah. So here you can see there are various libraries which are kept. A simple library file like this, just like your Word file again, you can store all the libraries within that and open it without any issue. It is simple. Every file is again compatible to MS Office. That means you copy this format. For example, I'm copying here, and then I go to Excel, and I can directly paste the values. And this is very highly useful in case of data manipulations. So you can do it vice versa. You maintain all your database in this, then copy paste in your library, and it's easily done. And you will find this flexibility in many of the softwares. So this is the main advantage. So this makes it much more suitable and flexible for university application where you can maintain everything as file based, making it highly flexible. In case somebody is working on a file, you can just save it as a file and then send it an email, and somebody else can start working on that. Or some person can start working on the libraries and they can use it later on forever. No database crashes, nothing. It's a simple file which is getting saved. So that's one thing. And then in the university licenses, majority of the time, the limitation is that you will have a node limitation, maybe around 50 or max to 5,000. Some of the licenses may give, but it for not for all the modules. So what we are doing it here is for research purposes. We have opened up all the modules. For university license, you will get all the modules ranging from the basic load flow to the transient stability for unlimited nodes. That means there's a practically no node limitation which is kept, and these are you can simulate any larger network and support any state utilities or any discoms in which pilot projects you can participate and start helping out the people and take practical problems onto the thing. And that is about the no node limitations on the software, and no module limitation. Also, we are activating almost everything of the package except for some of the premium packages. All other things are being activated. Libraries, as I told you, this is one library of transmission lines and two winding transformers I've shown here. Every component you can make a library without any hassle. You just right click, either you can just click on new library, and you can create for all the components any of the components which you want to which you have standard data you can put. And for the licenses, as part of it, we are including some of the standard libraries which are there, which contains the transmission line data which are used in India. You have that library here in the system. So we are including some of the libraries which are standardized so that you can start your base work along with the license. And another advantage mainly is the overcurrent device modeling is very much simple. In other softwares which you are already using, you might have seen that protection modeling is quite a difficult job. You have to model it as a block diagram for just like a control circuit diagram, and then we have to model all the relevant logics. Then only we can simulate protection coordination. Did you have to work on this Dixon protection coordination, ma'am? Anyone? Hello?
Snehal madam, could you please be interactive to so as he'll come to know what is your expectation level and already some of the experience with other software, please?
Yes, can you repeat the question, please?
Dixon Power Factory. Did any of the faculty members or anybody or they got a chance to work on protection coordination, madam?
Yes, we already have projects, MTech projects where students are working.
Okay, so that protection library, when you work on protection coordination on Big Silent, so the relay modeling, it might have been observed that it's a quite lengthy process, right?
Okay.
Because you have to enter it as a control diagram, create a module for it, and then keep on. There's a very lengthy process. Whereas when you look into this particular NEPLAN model, everything is included, including protection, I would say, which you will not find it as straightforward in other things. Including protection, everything is pretty much straightforward, drag and drop. So what in case I had to model a relay on this, in this particular line, okay, all I have to do is I drag a current transformer, I place it on this. So the program will take care, it will do all the allocations and everything. I specify a simple CT ratio. Then if I have to connect a relay onto it, then all I have to do is just go to the relevant relay, pick it up and drop on the CT. Again, the program will take care in linking the characteristics. And inbuilt are a large library of characteristics of relays. here I'm showing you the characteristics that are available. So all these gammeto characteristics, including IC inverse, IEEE, ANSI, IEEE U1 curves and C37112 curves, and all, including the custom defined curves also. So there is a large choice of curves that can be modeled, and there is also a protection library provision. In case we are not able to start up with this, there is also a library provision in which you can simply select it from the current library. Yes. So we can select from the NEPLAN provides yet another file-based protection device library. So where you can store all the protection device characteristics. So like here I'm showing there are various ABB circuit breakers and fuses which were modeled and kept as a library. So this, if you just open, relay, no relay in library, गलत वाला लिया है, but no, that's okay. This is a relay I have placed, no? I opened the circuit breaker, that's why. So so here there are a lot of characteristics that are that you can store once it is modeled. So I select from that, and then all the curves, relevant curves, will appear. So this is this kind of straightforward modeling is there for the protection devices, unlike the other softwares where you have to build up a lot of effort in loading the libraries and all. We have a simple file-based mechanism for the library files as well.
What about the CT characteristics?
CT characteristics in sense means you can model the saturation, knee point voltages, and CT residual fluxes, and loop CT resistances, and this can also be more modeled for what do you call CT adequacy check can also be done with this.
So are standard CT ratings available as per IEEE standard?
Yes, ma'am. You see the ratings here. The secondary rating is like this only, and primary ratings can be anything. Whichever are standard are already built in. 1 and 5.
I mean to say the characteristics are also built in?
Characteristics in the sense? The 5P and 10P accuracy class, yes, they are built in. The limit factors which are there as per IC, they are built in. The burden classes are also built in.
Okay.
And you can choose between the standards also. IEEE C37 if you want to see, then accuracy class C and K are there, and secondary terminal voltages are also maintained. So as per the standards whichever are there, they are all built in the software. You can also define the burden of the individual windings. The loop resistance also you can put cable between CT and relay. This is basically used to check the adequacy of the CT when you specify a relay. So that also can be put. And
can we view the characteristics here?
Sorry, ma'am. I don't have a ready-made example for that. I had to search from the project. This one I haven't built any characteristics in the sense that is you mean the flux characteristic, huh? Just saturation characteristic.
Yes.
Okay, just let me pick that up. Oh, here it is. Protection. I think I don't have an example for that, right? But I can show you that we have a. You can take it out from the examples which are from the projects which were taken. Adequacy check is not there in this. I can supply you with that example, and that's not a problem.
What about the other relays? It's only the overcurrent that you can.
See, maximum overcurrent. Then there are other variations here, which are called voltage relays and power relays, pole slip relays. Various signals can be monitored basically. Of course, it doesn't have differential protections incorporated. Differential protection directly is not there. Any like your generator protections, overcurrent and everything can be simulated, but not like unit protection. The stator earth fault and all those cannot be simulated in this.
Distance protection?
Distance protection, yes. Distance protection comes up in here. Z, it comes up here. So here you can, it is quite elaborate modeling. So there again, you can take from the libraries, and it has a polygon or circle settings for the characteristics, and then the different characteristics for the things defined here. This I have an example. I can show you that. Protection, distance protection. So here, there was a graph that comes up. Show setting. Yeah. Edit. Which me to name as let be set. Plot का है no, not that, not that. Here it will come here only. It will be here. There's my module actor नहीं दिया क्या? Yes. That's right. So here in this, you can see, ma'am, this is a polygon characteristic that is modeled. Okay, so the same thing if I put in here as a circle. Yes, this is polygon. Circle रख के मैंने किया नहीं है. I can change it here and then run it. Okay, this is a read only. I cannot change. Fine. Yeah. So as I was saying, you can see the impedance diagrams here. This is a read only example. I'm sorry. So I'm not able to change it completely. So here the various zone 1, zone 2, zone 3 characteristics are shown, and you can also display it based on. You see here I'm picking zone 1, then the characteristic is visible here, and if I say I can also choose to forward or backward, whichever is here. For this particular thing, backward is not defined, only forward is defined. So 0 plus onwards it is defined, so that is showing. Similarly, zone 2, it gets highlighted here, and the corresponding characteristic is also seen here. And if there are any, there is other features like power swing and all. If activated within the relay, you can see that also. So distance relays, and here you can define the kind of setting, whether it's a polygon or a circle. Circle type, that means more relays and all. So that you can specify here. And current and voltage transformer data is also fed in the same screens. So everything is pretty tab wise it is oriented on this, and the data can be entered by clicking on these respective things. No multiple pages or no confusion regarding what has happened in the earlier sections.
CT and PT is inbuilt, or we need to connect?
CT we have to give it here, ma'am. There is a model here, no? So we have to put the corresponding CT. This CT model will be standby. So and this relay will call on the data from here. Use CT or CVT from VT from the network. This is there, no? So that it will automatically call in. We have to place the relay on that particular CT. So we have to place that particular element, and VT is also placed here. You can see here. So VT is under protection switches. You can drag the voltage transformer and keep at the bus. So VT is also modeled here, just like a CT, but this has both sides voltages as customizable. So this is the data that is required for the VT, nothing else. And CT, since you need it for burden calculations and all, so the additional data is there. And these are pretty standardized secondary ratings, so they are built as a drop down. Otherwise, other than that, there's no other issues. So we have to model these two, and then that corresponding input is taken inside the distance relays. So up to this, it is there. The thing is, differential protections and all are not there in this, because those are specific unit protections which are, calculated printed as per the relay logic that are specified.
What about PMUs and PDCs? Are they available?
PMUs and what the other one? What is it, ma'am?
PDC?
PDC, phasor data concentrators and phasor measurement units. So these are normally used for state estimation and or for making a dynamic analysis in transmission systems. So the major purpose of these two will be to provide an input signal of the current state of the network at a particular point where the transmission interface is. So that will be taken as an input here. Means whatever equivalencing source we are doing, so that can be taken as a network feeder element, and here we can feed the phase angles and the slack proportions, etc. So, and from the protection point of view, so those are morely like what I would say is your whatever data you're getting, you can create the same data by or verify the data by looking at the response of the network in dynamic simulations. Phasor measurement units and phasor data concentrators are input devices, ma'am. So there's no direct interface like a SCADA or EMS for this. But we can take the inputs from those and can feed in this to say that, okay, this was the kind of phase angle that is existing at this bus. And this is the kind of short circuit level existing at the equivalencing bus. I hope I was able to answer your question, ma'am.
Yeah, and I was looking at particular modules of that.
There's no specified module as such, because from phasor data and data concentrators, okay, what is the data we are expecting? What is the kind of data we are expecting, and the state of that particular bus, voltage and phase angle?
Yes, fine. That is what I wanted to. That's all.
Yeah. So that that data is made as in feed into this particular network feeder element, which is a grid equivalencing element. So with that, we can check how is our system responding. For example, let me take a wind power station example. Let's say the simplest one. So here, I have a hypothetical wind farm getting connected into the grid. Okay. So for this grid, I have this phase angle and everything. What is the fault level? Everything. This is we are feeding it here. The expire ratios and everything. And then once we run the dynamic simulation, so these states, the different states can be calculated by the software. Now, if we look into here, we are just plotting the turbine control, the wind speed, the beta angle control and everything. Now, in case we want to select more and more signals always here there is an option. All the kind of parameters for the machines can be plotted directly by selecting the relevant variables. All you have to do is select something and add variable. Where did it go? Actually, I didn't select the machine. So I click here and then just say add variable. It keeps on adding here. So the how many number of variables I create, so that much I can just add and plot. So the phase measurement unit data can also be plotted like this. So other than this,
Okay, please go ahead with your presentation. Please go ahead.
yeah. Yeah. So going on with the other main activities. So libraries, we have seen now that we can create libraries for the uh, different network elements, including generators, transformers, and lines, and as well as the protection devices. Now, the other key thing is the libraries for regulators or what do you say, the kind of governors or IEEE defined AVRs, power system stabilizers, etc. So if we have to model that and try to simulate the things, so that itself is a humongous task. So all the other models which are needed for dynamics, okay, so those are inbuilt into the software. I'll just show you a glimpse of that. So if I have to choose any regulators or something, yeah. So NEPLAN has inbuilt exciters, power system stabilizer, under excitation limiters. They're kind of HVDC master slave controllers, VSC controllers. So different types of regulators are inbuilt, whichever are defined or are available in the standards. For example, if I take, and let me take power system stabilizers. This may be okay, let me pick it up from this. Okay. So that's exciter. Yes, here it is. So for example, I'm showing the exciters here. So if you select any of the model, install here. Yes. So if I'm selecting any exciter models, IEEE defined exciter models, so I get the default parameters along with the constants here, and you can also view the diagram, corresponding control diagram here. So without referring to the standards, we have all the references of the control diagrams directly. So the students can also, when they're working on this, a student or any research associate or even the faculty, when they're working on it, they can directly refer these constants without, again, going through the standard documentation and everything. So all the constants can be simply changed using a Excel template again. Every data is directly Excel compatible or MS Office compatible, I would say. And if you copy paste from here and you want to put it in a Word document or something, you get it directly without any issues. Unlike other softwares where you have to follow that particular report only. So all the report templates or any data to that extent can be directly used within MS Office packages or even Open Office. I will not say there's a compatibility directly. Up to MS Office, yes, there is a complete compatibility. It can be directly manipulated, and this is very much helpful feature in when the reports are being made for this projects. So then next I have some governors. Similarly, the governor types are built in, and then I have power system stabilizers. So there are certain power system stabilizer models also as per the standards that are built in, along with the relevant default data and the control diagrams. So biggest advantage is that you have a huge amount of dynamic library already included within this. And in addition to that, NEPLAN has a Simulink sort of a mechanism where you can make your customized control diagrams as well. So similar to MATLAB or Simulink, you can make customized systems. Where is that thing? Yeah. And you also have to an extent, we can simulate the inrush. I mean, inrush current of a transformer, how much if you want to check. So that also can be done in NEPLAN. This is a EMTDC software feature which is built into NEPLAN. For example, if you have a transformer which you want to check for inrush, then in the dynamics you have RMS, EMT, and in both DQ0 and ABC formats. So that means phase-wise analysis can be done, and DQ0 transformation analysis can also be done. So if we choose EMT, you can do EMTP analysis. If you choose RMS, you can do the regular transient stability and all. So this is another quite unique feature which is there. So in which here I'm simulating the transformer inrush phenomena, a theoretical example which every student can understand. Which every faculty member knows of this. So this is a inrush current which we are simulating here. So this normally we require PSCAD for this. So to the inrush simulations and all can be done in NEPLAN. But of course, not every feature of PSCAD is present in this. For example, if you want to do cable energization and all, that can be done to an extent. But if you want to simulate microsecond wise, so that is microsecond wise simulation like lightning impulses and all, those cannot be done in NEPLAN. Only switching analysis is possible. So this is another unique feature which combines the EMT power of EMTP also within the software, which you will not find in any other softwares. And it is helpful to make the students understand in a very easy manner what are all the fundamental concepts, starting from the transformer charging right up to the distance protection. All right, and then another thing is this: you can export the data of NEPLAN, okay, into PSSC. You can export the PSSC data. You can export it in an SQL database. Sorry, you can import. You can import the PSSC files. You can import the IEEE CF files. So these can be directly imported, and you can build in the networks. Majority advantage is if you have PSSC files available from some utility, so you can simply click on PSSC file import. The power flow raw data, sequence data, and dynamic data can be imported, and network will be automatically created within NEPLAN. So this is one of the another important features. So it has a direct compatibility to import from PSSC, which is another standard software used in the US region. And the other features which Shailesh might have explained in the last presentation, which I will repeat for some of the new persons who are joining within this call. So another main advantage with this is the main thing for the software, it should be like I should be able to experiment the things and self-learn the things. Okay, so for example, load flow when we run, every software will show you the PQ and voltages and other things. Okay, and the specific interpretation has to be seen whether the P is absorbed or being supplied within the network. For example, if I have a generator here, I see a -10 and -10. So what does this mean? And does it change anything if I have some other network conditions? And what is the performance of the network? Some graphical indications have to be there. So for that purpose, NEPLAN has the flow animations where you can clearly define clearly show that the power flow, how it is happening in the network. Okay, if you're seeing that power flows which are being coming. So this will indicate clearly that what are the things, how the power flow in the network is happening. You can customize the arrows for P and Q separately, which will make the things easier for students to grasp. And also, one more thing is, let me stop this flow animation. It's not. Another major thing, animation is a very basic thing. That's not an issue. Then another powerful feature is that you can have a visualization of the network performance either in the form of a contour diagram, depending on the, if it is a load flow, it is simply the percentage U and power and reactive power and active power. And main strength lies in the reliability. Reliability indices also can be shown as a contour diagram. Of course, I don't have reliability data in this, so I'm showing the load flow visualization. So here I'm showing the voltage profile in terms of a contour diagram. Now, similarly, imagine if we have a GIS network and you're calculating reliability of this network. Then the various reliability indices of the network can also be plotted as a contour, which will give a ready-made indication of the weak areas or the actionable areas within the network. So this is yet another powerful feature which you will not find in any other analysis softwares. And also, if I don't want this, okay, I am not looking about the background, but then I want to see the element loadings within the network. This is not activated. Put it. I've activated it. Show result visualization. Wait. I have to remove this. So here it is giving a gauge-wise indication of the voltages of the nodes and the line loadings, so that even if you're in case of a larger network, you don't have to look into the exact values. Just even if I remove the results, I don't want to see the exact values. I just want to know a glance of how much my network is loaded. Then simply with this pie chart loadings, we can get a understanding of what is the problematic areas. Here, I don't have any values displayed, but you can see here, if I see a orange color display where it is showing a lesser voltage. So those can be readily identified. So this is yet another powerful feature. Okay, and the main other features like harmonic analysis are also made quite simple. And the interface with the analysis is via simple drop-down menus. The analysis can be selected from from this drop-down. For example, if I had to choose a harmonic analysis, I click on that drop-down and then you click on the harmonic analysis parameters. It's in the same context, it will come up. In the harmonic analysis also, the complete analysis package, starting from the frequency scanning to the harmonic level calculation, that is THD and THDI calculations, with the flexibility of choosing the results which you want. That means I can select the elements which I want a harmonic analysis. I can select the results for the nodes also, or I don't know which have to be selected. Then I can simply select all or none. So that kind of complete flexibility is given in the software to choose the relevant analysis. And also in harmonics, you can directly plot the kind of harmonics that are present in the network. For example, here I'm showing you one of the harmonic source that is present. So I have modeled a motor here within the network, which is creating a problem, and we can design the filter which is required for that using this software. So the harmonic analysis, this is the harmonic spectrum which is there. So when I plot the harmonic content, so this is how the total load current looks like. So we can plot it. You can either export it or just copy And as I told you, you can copy and it will directly appear in the MS Office packages. So I just I clicked copy and then I pasted into a report. So of course you can create grids and other manipulations on this. So with this you can generate with this kind of networks you can also design the filters. So here I'm showing some of the filter parameters here. So you can design a specific order filter by changing the values here. For example, if I want a 250 hertz harmonic filter, then all I have to do is I put 250 here and put it, the program automatically calculates the relevant parameters required for the filter. And accordingly, your QR and all everything will be calculated. So this kind of easy interfaces for complex harmonic analysis is also given within the software. And in case you want to define some, you don't know how much reactive power is needed, or you want to define something, then there are various methods that are available. Switched admittance, continuous, discrete, and all are there, so that you can know the amount of reactive power compensation required directly. And then one of the other things is investment analysis. What the powerful feature of NEPLAN, which you can which you can say is mostly in the same database, you have the investment data also. That means for every component that I'm modeling, including this bus bar. Okay, so in this, if we click on other analysis tab, you can put how much is the cost for that, what is the tax and maintenance, what is the price inflation, everything can be inputted, and the corresponding NPV of the project can be calculated. So tax and maintenance, inflation, the currency, and base price year levels, planning period, and how much is the power cost and the energy cost. That means fixed cost and your energy level cost and the loss factors, everything can be defined, and the year of investments can also be defined for this. So what happens is, in a large network, that means, for example, if I assume this is a network, I can keep on adding assets to it. If I'm an industry, I can say that, okay, in 2025, I'll come up with a motor of this much of value. And I can make based on the losses within this network and other factors, I can make up what is the payback that I'll get with the proposed modifications. So it combines the technical analysis and the financial analysis, which will add a completely new point of view for the studies that are done. For example, if I tell a student, okay, you work on capacitor placement. Okay, I take up this. I have a small feeder. Okay, and it is feeding some distribution transformers, and I ask a student, okay, or a research candidate, say, okay, you propose the best way to reduce the losses in this network by taking up a capacitor placement or something. So now that is a technical assignment. He may choose a genetic algorithm or whatsoever and try to compare the results. But then, what is the financial implication in field? If you have to, or in practical, if you have to get something, it also should have the financial viability. So for every element I have in this network, including this line segments, everything we can add the financial data. You can put the year of investment. A timeline can also be maintained, and then you can arrive at the net present value of the network based on the loss reduction and everything. So this will give you an output of NPV. Let me open another example of that investment analysis. No, it was there here somewhere. Yeah, here it is. So investment analysis, if you see here, you can see the various boxes that are coming up. Now this I haven't discussed with you. The thing is, NEPLAN has a variant feature in which I can do a what if analysis to an unlimited number of scenarios. That means if I have a base network, for example, here for investment analysis, they have taken up a small network. Okay, we have built a small network here. Now this, what will happen if I switch on this capacitor, what will happen if I switch on this particular capacitor. So every time I need not modify in the same network and do it, I can create different scenarios here. Now there are once I create another scenario, the exact network completely will come up in addition to whatever other modifications I make. So if I close this variant and I open up the next variant in here, here what is done, both are switched off. And it's coming to the investment analysis. So here what we have done is we have created various scenarios for each of these simulation, 2 capacitors at 1.0, 2 capacitors 1.2, no capacitor at all. So there is some series of scenarios that were created. Now I can prepare investment analysis for this. Let me just run it. So here I'm these compare plans. We can add or only that plan or compare. We can compare the various scenarios, and the package directly shows you how much is the investment cost with inflation, and then the net present value of the proposed project for different elements. So BCR and PBP, payback period and benefit to cost ratio. For all the scenarios, how much is the losses and what is the benefit to cost ratio and payback period. So these can be displayed. So this makes the analysis totally a 360-degree analysis. That is from concept to implementation, where you are taking up even the financial aspects. So this is another major important feature. And then you have voltage stability and small signal stability modules are also included for the university research package. Colors are pretty much standard. That's okay. That's yeah. Another main thing is, for example, if I'm calculating a load flow analysis, okay, now I choose an investment, but I'm choosing I don't know what data is needed, or a student doesn't know what data is needed for the load flow. What is mandatory? I have so many data. What all I have to fill in? So there is reliability data is there. So do I have to fill in everything, or do I have to fill only certain parts of it? So that also is made simpler. I can choose the kind of analysis I want to do. For example, short circuit data. And then I can choose this particular color, whichever color I want to, and then ask it to be highlighted. So this is the minimal set of data which you have to enter for that particular analysis. So do I need it to enter anything in limits? No. Regulation? Yes, because taps will define the short circuit. So this is needed. So do I have to enter anything in dynamics? Here I don't need anything. So like that, it will give an indication. So any person who is straight away start to work on this can work on the software with minimal intervention, and all the possible vector groups are also included in the transform models, along with the data set which is needed for the tap changes and everything. So I think this is the things which I wanted to convey, and the modules which are given are completely covering all the areas of our industry systems, transmissions, and generation systems as well. So you can use this software for any sort of the features that are required, and everything can be modeled. Of course, there are some other dynamic diagram features and everything which I did not go into, because that will look into when the detailed software training is there. So with these features, what the best thing that can happen is the industrial collaboration will be much easier, and students can also work on the softwares which are there on a software which is used in the grids, standardized grids all over the world, and they can also work on some domestic projects as an intern project. So they can take up the data and start modeling in it and start correlating the results with the practical field results as well. Yeah, so this is something which I wanted to share, some of the key features.
Are all the renewable models available?
Yes, ma'am. So renewable models, DC and smart grid, there's a category. Under this, the flywheels, DC reactors, and then single ports may dispersed generation is available here. And in this, the wind, photovoltaic, renewable energy, fuel cells, static generators, and the different WTG models are included in this. From load flow point of view and dynamics, you can have a IEC WT genset data as well. So whatever standardized controllers are there. So this, as I
So,
told you,
power electronics is not a part of the software, right?
power electronics. I would say like the detailed buck boost converters, the VSC, the diode mechanisms are not part of this. This
Because
main
when you
software.
go for renewables, you need interfacing with these converters.
Uh,
So,
Ma'am, there's one difference here. What I would like to say is, once you have a renewable generation, okay, and you're doing a power system analysis, so
mm-hmm.
what is of main interest is the overall capability of that particular solar inverter or the wind generator. How much is the control capability of it, and what is the active power and reactive power output of those, and then the corresponding control circuits. But
To have a DC microgrid kind of a thing.
mhm.
I want to analyze the
DC
DC
systems,
micro.
yes, they can be simulated. DC systems can be simulated, but what I would like to maintain
No, but
here is,
suppose I have the AC grid also as a part of it, or I mean to
mhm,
say, is interface through some renewables.
yes, yes, I'll show you that also. Wind power stations. Where is that example which we opened earlier? DC photovoltaic array. No, not DC load. Oh, the other one. Just give me a sec, ma'am. I have something for that also. I think this one or this one with PV penetration. This one only. Yeah. Open करके रखा था. So there are some blocks in NEPLAN which can handle DC as well as AC. You can see here this particular system is a DC node. Okay, so the DC node with the solar generation. Okay, the set voltage generator here. Okay, so this, and there is a PWM converter model with the relevant power flow parameters again, and then you have an AC bus. You can see this is a node which is AC bus. So we can combine both the DC systems and AC systems, and the relevant converter models have been built into NEPLAN. So if you see here, this solar photovoltaic converter, and it is interfaced with rest of the AC system, the AC generators along with the AVRs and all. Here also you can see this is a DC photovoltaic which is being modeled, and then they have a PWM converter which connects to the AC system. So this kind of simulations can be done. What I meant was, within this PWM converter, like your PSpice and all, if I have what is the voltage at a particular thyristor or a particular transistor, so that is not possible. But as a VSC, the converter itself wholly can be simulated, and you can do the AC and DC system analysis together. But yes, if you want to see what is the performance within the converter, so that is not possible in NEPLAN, or in fact even in Dixilent or ETAP, because these softwares are meant for the overall power system analysis, not within the component analysis.
Okay.
Hope I answered your question, ma'am.
Yeah, I got it. Thank you.
Yeah. So I think we can take up questions now. Anything related? I've just quickly shown a glimpse of all the things which I felt those are major from the academic and industry collaboration criteria. because we encourage people, students to take up projects in this and then work on the actual things so that you know they can get much easier internships and all.
Okay.
So as
Yeah, I'm thankful for for this presentation and including whatever points I had asked. And that is for all from my side.
okay.
Snail ma'am, I hope you are satisfied and have no question now.
Yeah, that is what I mentioned, Pankaj.
Yes. And Raskar sir, anything from your side?
Please give some demo on distance relay or differential relay.
Okay.
All demo. If you want.
Demo means what?
Different differential, as I told
Sim-
Mr. Raskar, it is not available.
distance relay.
Distance relay, yes. You can simulate the distance relays within NEPLAN, but you want demo in the sense, yes, we can do that as part of the training.
Some simulation.
Yeah,
Small simulation or characteristics.
I have shown that part in the demo. Okay, let me repeat that example. If you want me to take through how do we do the setting and all, that will be part of a detailed training. Okay, but I did show that example where this distance protection is modeled. Yeah, so this was the modeling and all is possible with the distance relays, along with the circle and polygon characteristics, and we can edit the impedance diagrams, the zone 1, zone 2. This I have shown, right? So zone 1 characteristics and zone 2 characteristics. Now I got your question. You were saying, okay, give me an example and help me and put this in it, right? So that we do as a
Yes.
part of the
Yes.
training, sir. Normally. But here the purpose of this demo is to show the capability which is present in the software. So specific examples we'll formulate as per your requirement, and then we can show it. That's not a problem. But the thing is, if these features are present within the software. Yes. Any further questions, please?
Snail madam?
No, sorry.
Yes.
This आदत पड़ गया उसमें. Teams में आदत पड़ गया. Yes.
Yes, I've already communicated that I had finished all the questions, and I thank all for the presentation and addressing whatever points I had asked.
Okay, thank you, Snail madam. And with you, I mean, Dambara sir was there, madam?
No, I think he was not able to join. He might not have finished his earlier meeting.
Okay, okay, fine. But whoever, I mean, relevant people were there to check the qualities of the product, ma'am?
Yes, they were there for some time. So it would be good if you could share this presentation recording if possible.
Yeah, that recording link we will share you. And then should we conclude, ma'am?
Yes, yes, please.
Okay,
I
I'll
think
talk
we
to you.
already exceeded.
Yeah, I'll
the-
talk to you later in this apart other issues. And once again, I'm very thankful to Trininath sir and Shailesh ji for conducting this demonstration. I mean, twice for COEP. And on behalf of COEP, on behalf of IndiaSoft, we are really happy to know the advanced features of NEPLAN product. And with this, we conclude this meeting. Thanks, and I'm very again,
Thank you.
showing our gratitude to all you people who have joined this meeting, even from COEP, all faculties. I'm very thankful to all of them.
Yeah. It has been a pleasure interacting with you all. Thank you, ma'am.
Yeah,
Thank you, sir.
thank you.